So today we shall see what is the excitation table. So for excitation table is a table that indicates what are the inputs required to be applied to the flip flop. That is, we are writing the inputs of the flip flop from the present state and next state. So let us write the excitation table for a SR flip flop. The truth table of SR flip flop is S R, and the conditions are 0 0 0 1 1 0 and 1 1, and the next state is given by qn plus 1. So for 0 0 condition, the next state there is no change. So if qn is the previous state, that will be the case for 0 0, and for 0 1, since s is equal to 0, the output will be 0. Since s is equal to 1, the output equal to 1. For 1 1 condition, it is invalid condition. So this is the truth table of a SR flip flop. Now we shall see what is mean by excitation table of a SR flip flop. So to write the excitation table, first what we must know is we must write the present state and next state. So given the present state and next state, we have to find what are the inputs to S and R. Okay, so this is the how we are deriving the input. So given present state and next state, so if present state we are denoting it as qn and next state as qn plus 1, and from that you have to find what are the inputs. So such a table is called as the excitation table. So since there are two conditions, ps and ns, the different possible combinations are 0 0 0 1 1 0 and 1 1. Now you have to find what are the inputs for S and R depending on the present state 0 and next state 0. So for that, what you have to do is you must see what is the what should be the input for S and R. So when it is 0, for there are two chances for the next state to become 0. When S is equal to 0 and R is equal to 0. In that case, the next state can be output will be 0. And another possibility is that this is actually no change. So the no change condition is this S equal to 0, R equal to 0. Then another possibility for the output to become 0 is S can be 0 and R can be 1. In that case also the output will be 0. Okay. So from these two, what we can see is that S is always 0 here. From this, R can be either 0 or 1. So from that we can say R is, we need not consider because R can be either 0 or 1. So we can take it as 0, don't care. So when the input is 0, don't care, the output or the next state will be always 0. So this is the first case. That is, for this state, the value of s and r will be 0, don't care. Okay, that is for the present state. If it is 0, for the next state to become 0, there are two chances. First one is says that s can be 0 and r can be 0. This condition is a no change condition, so this output will be 0 in that case. And next possibility is s can be 0, r can be 1. In that case also the output is 0. So there are two cases where output becomes 0. There is present state changes to 0. One is 0 0 condition and another one is 0 1 condition of SR. So in both cases the output is 0, as you can see. So this we can write as s can be 0, s is always 0. So that's why we are writing here s value as 0. R can be either 0 or 1. So that's why we are writing it as don't care. So now we can write the truth table for there I can write the excitation table value. So this is the calculation. So the excitation value will be, for this case, the value of for input s and r will be 0, don't care. Okay, so that is first combination. We have found what will be the input of s and r for corresponding change of present state from 0 to 0. Similarly we can find the other combinations also. Okay, the other combinations will be, so the next combination to be checked is 0 1. So this we have checked, that is 0 0 case the input of s and r will be 0, don't care. Now next we shall see what should be the input of s and r when the present state is 0 and next state is 1. So the output has become 1 from 0. Okay, from 0 the output has become 1. So what are the possible inputs of s and r? For the output to become 1, s can be 1 and r can be 0. That is one possibility. Then second possibility is that there is only actually there is only one possibility for the output to become 0 to 1, because only when s is equal to 1 the output becomes 1, because if the present state is 0 then next state can become 1 only in this condition 1 0. All other remaining condition, that is 0 0 means it is no change, it is not possible. Then 0 1, 0 1 means the output will be 0, but here the output is not 0, it is 1. So this is also not possible. Then 1 1 condition we can see. In 1 1 condition we can say it is invalid, so we cannot take that. So the last condition which is remaining, that is 1 0. For this condition it is okay, that is the output will be 1 because s is 1. So this will be the excitation value for s and r for the case present state is 0 and next state is 1. So the last case which you have to check, not the last case, the third case which you have to check for is the, so this will be the input for SR when the condition, the state change, present state changes from 0 to 1. Now the next state to be checked is the 1 0 combination. So for this combination we have to see the state changes from 1 to 0, the output becomes 0. For SR flip flop, the output to become 0, the S has to be 0 and R has to be 1. The remaining combinations are not satisfactory because 0 0 is no change, that is not possible. 1 0, the output becomes 1, that is not possible. 1 1 is invalid. So only condition which is satisfying the present state value is 1 to become 0, the value will be 0 1. So that is the excitation for SR for the case when the present state changes from 1 to 0. Now the last case which you have to check is the 1 1 condition. 1 1 condition means the output is changing from the output is changing from 1 to 1. So we shall see what are the possible cases. Present state is 1 and next state is 1. So for the next state to become 1, what should be the input of S and R? So when S equal to 1, that is possible. That is one case. When S is equal to 1, it is possible that we can get a value S is equal to 1 and R is equal to 0. We can get the output as 1. That is possible. Now next possibility, that is, there is, from this we can see there is no change. So no change means the next possible case is 0 0. So if the present state is 0 and the inputs are 0 and 1, 0 and 0 that of SR, then there is no change. So these two conditions are satisfying this transition, that is 1 to 1. That is present state is 1 and next state becomes 1. The remaining combination, that what is remaining is 1 1 condition. 1 1 is invalid, so we cannot take that. Then 0 1, 0 1 we cannot take that because the output becomes 0. So these two remaining we cannot take. So only possible condition which it is satisfying this 1 to 1, that is a present state is 1, output becomes 1, is these two, that is 1 0 and or 0 0. So S can be 1 or 0. From the picture we can see S can be either 1 or 0, but R is always 0. So if S is always 1 means it is S is 1, S can be 1 or 0, but R is always 0. So this we can write as S can take either 1 or 0. So this value it will be in don't care. We did not consider because S can be either 1 or 0, but R will be always 0. So since R is always 0 means it will be always 0. So instead of don't care we can write 0. So for the last case, that is 1 1, what we can understand is that the input of the S and R should be don't care 0, so that we can write in the same row. It is in here we can write don't care 0. Here it we already wrote it is 0 1, and this one we have written don't care 0. So this will be the completed excitation table for SR flip flop. So this is how we find out excitation table for a flip flop. That is, you have to find out what are the inputs of the flip-flop required given a present state and next state. So given a present state and next state, what you have to do is you have to find what are the, given a present state and next state, you have to find what are the inputs of the SR. So this, what you have, this table is called as the excitation table of SR flip-flop.